Hello friends, let's see another gate question. Again, it's look like a very lengthy problem. Let us see what will be the solution for this. A square footing 2 meter by 2 meter is subjected to there is an inclined point load as shown in the figure below, right? The water table is located well below the base footing. That means water table will not have any effect on this. Considering the one-way eccentricity, okay, fine. That means, see, if it is a 2 meter, what about the CZ point? That will be at a 1 meter. The load is acting at a distance of 0.85 meter. That too, it is acting inclinedly. So let us see what they're asking. They're asking us to find the net safe load carrying capacity by considering the factor of safety. What about the net safe bearing capacity? Net safe bearing capacity, I can say it as a 1 divided by factor of safety of net ultimate bearing capacity. They're asking in terms of the force. Let us find out in terms of the pressure and then we will convert that into a force. Let us see what they're given. The bearing capacities, as it is a directly cohesion is given as 0. That's why NQ value is given and gamma value is given. See here, shape factor is given, depth factor is given, inclination factor is given directly. See, it is a rectangle footing. If nothing is given, then what will consider? If you remember, we are considering if it is a square, if it is a circular, if it is a rectangle like that, we are considering 1 plus 0.3 b by L or simply 0.3 like that, we are considering shape factors. So here no need to consider that. Why? Because the shape factors are directly given, depth factors are also directly given, and inclination factors are also directly given. So if everything is given, then how can you find out the capacity, right? So here directly let us find out QNS. As C value will be equal to 0, so whatever the equation, gamma D NQ minus 1, if I am finding the ultimate net safe capacity. Here I can say net ultimate plus gamma B and gamma 1 by 2. So these are without considering any corrections. So here you have to consider inclination corrections, shape corrections, and also the which type of the correction? What is given question? Depth correction, inclination, and the shape. So let us multiply them. So Q and U, that is nothing but a gamma D into NQ minus 1 into depth correction, let us say FD, inclination correction, let us say Fy, and also let us say shape correction Fs plus of into gamma into B into N gamma multiply by depth correction multiply FD, inclination correction Fy, shape correction Fs. So see the data. As groundwater table is very below, gamma is given as how much? 18 kilonewton per meter cube. What is the shape factor? 1.314. And what about the depth factor? 1.113. Inclination factor 0.44. If you see here, the inclination factor, it is different for the Q value and also it is different for the gamma value. That means here I can say, here it is, as I am representing with respect to the Q. Here I'll say Q, FQI. Here I'll say it is a F gamma I. So these two values are different. And D value is given as how much? 1 meter. What about the width? 2 meter. That's it. Substitute in that equation, then you will get it as around QNU. You will get it as around 397.09. They are asking us to safe value. So what is the net safe pressure? That is nothing but a net ultimate divided by factor of safety. That is nothing but 397.09. What is the factor of safety is given? 3. So net safe bearing capacity, how much you can apply? 132.3 if you solve this kilonewton per meter square, right? So what we have to find? We have to find the load carrying capacity. That means we have to multiply this by area, isn't it? If you want to multiply by this area, let us see the plan of the footing. If I see the plan of the footings, on this side how much it will be? 2 meter. On the opposite side how much it will be? 2 meter. But if you remember, there is an eccentricity. So where the load is acting, it is acting at a distance of 0.85. So as already discussed, wherever there is a eccentricity, then your new width, that is nothing but a 2 times of the E. So what will be your new width up to which you have to consider the load? That is nothing but a hatched shape. They are asking us to find it in one's direction only. Either you consider along the width or you consider along the length. If they haven't mentioned anything, then you can consider eccentricity along the length also. So in the present case, what about your new width? 2 into 0.85. So what will be your new width? Let us say your B subscript X. 2 into 0.87, 1.7. And what about the length? We are considering it as a 2. So what about the safe load? Safe load is nothing but a, what is the shape pressure? 132.3 multiplied by the area. We should not consider the entire area. Why? Because as there is eccentricity, consider only the reduced area. How much it will be? Your new length to updated with 1.7. So if you are solving this, you will get this value is around 450 kilonewton. Got it? So here you have to remember only one thing, that until this step everyone can do it. After that, as there is the eccentricity, we have to consider the new dimensions. How we will consider the new dimension, that we already discussed in the theory class. So here also the important thing is, in the class we have discussed that in two directions we have considered, but in the present exam or in the present question they are asking us to find only in one direction. So this is how we will find out if we have to consider in one direction, right? So only the important thing is that everyone may commit the mistake in this value 1.7, right? Thank you.